Hello and welcome to our first set of notes since spring break. I hope everybody is rested and your brains are ready to learn some math. So we are starting a new chapter on area, surface area, and volume. Today's lesson hopefully will be mostly review. Also, the lesson is mostly already typed out for you in your notes. So if you are printing the notes, then you don't have a whole lot to write. And if you are writing the notes on your own piece of paper, just summarize these theorems and postulates. You can just draw a picture in the formula. That's fine, okay? So our first theorem is area of a square. And it says that the area of a square is the square of the lengths of its side. And so in our picture here, we see that the side length is s. So our area is equal to s squared. Our next thing is a postulate about area of congruence. And so this says that if two polygons are congruent, then they have the same area. Well, that makes sense. If they're the same shape and size, then they're going to occupy the same amount of space. Our next postulate is the area addition postulate, and it says the area of a region is the sum of the areas of its non-overlapping parts. So if I have a square here, or a rectangle, and then I have another rectangle here, and I want to find the area of this entire figure, well, I can just take the area of the top rectangle and add it to the area of the lower rectangle, and that will be the area of the entire shape. My next theorem is the area of a rectangle, which is the product of the base and the height. And so remember, base and height are always perpendicular to each other, no matter what shape we're talking about. So hopefully area of rectangle and area of square are familiar formulas to you. So now we're going to talk about area of a parallelogram, but first we're going to talk about what are the base and the height of a parallelogram. So when we talk about a parallelogram, the base is going to be either pair of parallel sides can be considered the bases. So the bases, I forgot an S there, are either pair of parallel sides. And then the height is going to be the perpendicular distance between those bases. So typically when we look at a parallelogram, a lot of times we'll consider the bases as the horizontal set of parallel lines, but it doesn't matter. We could take those diagonal set of parallel lines as well. So in this parallelogram here for the picture, we see that the bases are in blue, and then the height is going to be that distance between them, okay? So whatever the length of that distance, and you could measure it anywhere between them. It doesn't have to be right there. It could be any of those, but remember, those are all going to be congruent segments. So when we look at the area of parallelogram, here's kind of a picture that helps us understand the formula a little bit. So remember, a rectangle is a parallelogram. So if I stack these, let's say they kind of look like unsharpened colored pencils or straws maybe. So if I stack these colored pencils nice and straight, they make a rectangle. And then if I push them over a little bit, they make a parallelogram, and then I can make that parallelogram even more extreme. But altogether, those pencils are going to take up the same area. So my formula for the area of a parallelogram is just like the area of a rectangle. So it's still going to be the area of the product of the base and the corresponding height. So corresponding just means that depending on which base you use will determine which height you use. Okay, and there's a picture for us. Our next theorem is the area of a triangle, which hopefully is also a review for you. So the area of a triangle, oh, hold on, my dog needs to be let out. I'm going to keep talking while I walk over here to let my dog out. So the area of a triangle is half the product, not produce, sorry. So product, change that on your notes for me, please. Typo. Is half the product of a base and its corresponding height. Okay, so we get half of that. And here's a little, some pictures that can help us relate the formulas so we can help ourselves remember them. So if I take a parallelogram, which is in blue here, and I take the height from one vertex and go straight down, I get this triangle over here that I can then move to the other side, and then I see that, oh hey, I do in fact occupy the same space as a rectangle. And if I look at a triangle and I think about taking that triangle and rotating it, so this is an equilateral triangle, but it doesn't really matter. But if you think about it, and you can arrange two triangles, congruent triangles, so that they create a parallelogram. So we see that we get one of those triangles is half of the parallelogram. So that's why it's half of base times height. All right, so here are our examples. So our first example says find the area of PQRS, and it's supposed to have the parallelogram symbol in front of it, but I couldn't find the parallelogram symbol on the type, so it is missing. I apologize. So we know it's a parallelogram, so that's important. So what I'd like you to do right now is go ahead, pause the video, try the examples, and come back and take a look at them. Okay, so for example A, our first option is we can use PS as the base. Okay, so method 1, I'm going to do this two ways. Method 1, PS and QR are bases. Okay, so if I do that, then I know that my area is going to equal base times height. So my base is going to be 6. And then my height is going to be, remember, the perpendicular distance between the bases. And this one we can extend out here. So my height is going to be 8. And so then I'm going to get 48. And I don't know the units here, so I'm going to say units squared. I don't know what they are, so I just put the word units. Second method. So if I picked QP and SR to be my bases, so method 2, QP and SR are the bases. And I forgot my lines above my segments in that first method, so I'm going to add those. All right, so if those are my bases, then my area is going to be base times height, and my base in this case is going to be 12. And my distance between the bases, remember, has to be perpendicular. That's going to be that distance of 4 over there. So I get 4 times 12, which is 48, once again, units squared. All right, so regardless of which sides you pick as bases, if you have the information, you could do it either way. Sometimes you don't have the information for the height for both bases. Our next example is the base of a triangle is twice its height. Find the area of the triangle. It doesn't say find. It says the area of the triangle is 36 square inches. Find the base and the height. Okay, so let's set this one up. So if I have a triangle, oh, my other dog's barking now, and I know that the base of the triangle is twice the height. So we'll call this H, and we'll call this 2 times H. It goes from here all the way to here. Okay, and so I know that 36 equals 1/2 base times height, because my area is 36. Maybe I'll just write the formula up here, 1/2 base times height. So then I get 36 equals, I already have that, 36 equals base times height. And then I have, here we go. My base is equal to twice my height. So I'm going to replace that in my formula. So 36 equals 1/2. And then I have 2 times the height, which I replaced. So all I'm doing is replacing this B with this 2H. So that's all I did there. And then I still have that other H on the end. Okay. So now if I put it all together, well, hey, this looks nice because my 1/2 and my 2 will cancel when I multiply those together. So I get 36 equals H squared. How do I undo squaring? I take the square root of both sides. So H is the square root of 36. So my height is 6. And then my base is 2 times 6, which is 12. So my height is going to be 6 inches, and my base is going to be 12 inches. So remember, lengths are measured in one dimension. they only have one dimension, and then area are measured in 2 dimensions, and then volumes are measured in 3 dimensions. So that can help you with your exponents on your units. All right, here is our next and last example. It says you need to buy paint so that you can paint the side of a barn, pictured below. A gallon of paint covers 350 square feet. How many gallons should you buy? All right, so let's first figure out the area of this barn. So I'm going to redraw it over here. So it looks like we have a rectangle that is, 26 feet and then 18 feet. And then on top of that rectangle, we have a right triangle, which is a isosceles right triangle. So that's nice. So these are both 45 degrees. Okay. So, we have a 45, 45, 90. Let's see if we can remember our ratios for 45, 45, 90. So if I have a 45, 45, 90, I know that the short leg, or the leg, equals square root of 2 times the hypotenuse. Okay, and so my hypotenuse in this case is 26, because it's the same as the bottom of my rectangle. So square root of 2 times 26. So then I get that the leg, let's call that x, just so it's nice to have a single variable. So then that's fine. So x equals 26 root 2. Okay. And then we can figure out our areas. So the area of the rectangle is going to be 18 times 26, which gives me that's fine. So we have 18 times 26. And then my triangle here, we have, let's see here. If I look at this triangle and I draw it this way, I'm going to rearrange it. So I have the x here and the 26 here. I know my base and my height are both x because I already have a right triangle. Okay. So then my total area is going to equal area of the rectangle plus area of the triangle. Area of the rectangle is base times height. So we get our 18 times 26. Plus the area of the triangle is 1/2 times its base times height. And both its base and height are x. So I get x times x. So then I get 18 times 26 plus 1/2 times 26 root 2 squared, because I have x times x, which is the same as x squared. So when I put this all in my calculator and figure it out, I get 637 square feet. Okay, so you can do that on your calculator. And so now let's see if we answered the question. So the question said, how many gallons? Well, we figured out the area, but now we need to figure out gallons. So our gallons cover 350 square feet. So what I'm going to do is I'm going to take this answer. I'm going to say, okay, I have 637 square feet. And I know for each gallon, I'm going to cover 350 square feet. So my units of feet squared are going to cancel, and I get 637 divided by 350, which gives me 1.82, and the units left are gallons. So that would be my answer. Okay, great. So upload your notes to Schoology and try the homework. Let me know if you have questions.